Okay, this is another video on voting methods, and this one's called the Condorcet method, or the method of pairwise comparisons. So the idea with this, I'm using the same voting schedule here, preference schedule. The idea is, so B1, the plurality method. The idea is, since B1 plurality, you would think that in each of the pairs, B would win, like B was always chosen over A, or most often chosen over A. B was most often chosen over C, D, and E. So that doesn't always happen though. So one of the theories is that there should be a Condorcet winner, or someone who wins the most pairings. So let's try this out. Let me show you how this works. What we do is we count, we're going to write out the pairings. So A and B, A and C. So it'd be like if only those two were in the race. AB, AC, AD, AE. And I'm just listing them out in a systematic way so that I get them all and I don't duplicate. So I've done A with everyone. Now I'm going to go B. We've already done B with A. So B with C, B with D, and B running against E. That's all the B's. So then C, D, C, E, and lastly D, E. So this again is a little tedious method, kind of like the board account, but we want to, we've got to do it by hand so we can understand how it works. Then we would have computers programmed to do this. Okay, so the idea is to count how many times did voters choose A over B if only those two were running. Okay, so count how many voters if only those two were running. So I'll show you how we're just kind of going to ignore everyone else and see how many times did voters choose A over B. Okay, so when we look, okay, see, B was over A. B was chosen over A, so not that, not those three. Here, people picked A over B, A before B. So that's 4. Here, no. Here, 6 is A over B, so that's 10. Not here and here, so that's 11. And we know there's 20 altogether, so if 11 picked A, then the other 9 chose B first. So A, isn't that interesting? B was the plurality winner, but more people chose A over B in their rankings. It's just that no one put A first. Interesting, huh? Okay, so let's keep going. Now we're going to look at A and C. So I'm looking to see, where is A over C? Not there, not there, not there, here. A over C with 2 people, and also 1 more here. So this is going to be 3 and then 17 since we have 20. Okay. So 17 people chose C over A. Now let's do A and D. So A over D is 3 plus 4, that's 7. Not there, not there. Plus 2, so that's 9. And 1 is 10. So this one was a tie, 10-10 between A and D. Now let's do A and E. So A over E is 3, A over E 7, A over E 11, A over E 17, not there, not there. So 17, I'm just checking with my notes to make sure I don't mess it up. 17 picked A over E. Okay. Let's keep going. So now we're going to compare B and C. So B, that's my neighbor kid. I'm going to shut the window. I don't know if you could hear that or not, but if it would be distracting or not. Okay, so B over C. So B over C, we have 3 not there. 4 there, so that's 7. B over C, no. B over C, 9. B over C, 1, so 10. So 10 and 10. Another tie. Okay. B over D, 3. B over D, no. 4, so that's 7. B over D, no. B over D, 9. And that's it. So 9 to 11. So D, more people chose D over B. What the heck? Okay, B over E. B over E, there's 3 plus 4 is 7. B over E, that's 11. Not there. 12, 13, and not there. So 13 to 7. Okay, more people did choose B than E. Okay. Almost there. C over D. If you want to test yourself, pause it and try it, and then catch up with me. So C over D is 3 plus 4. No, no. Here, so that's 9. I think that's it. 9 to 11. Yep, so D wins that one. C over E. C over E is 3 plus 4 plus another 4, so that's 7, 11. Plus 6 is 17, but then E is higher in both of those, so 17 to 3. So C was preferred over E. Last one, D over E. D over E, 3 plus 4 is 7, plus 4 is 11, plus 6 is 17, and E was higher on those, so another 17 to 3. So D was preferred over E, 17 to 3. Okay, so that's all of the comparisons. And now we're going to see who was preferred in the most pairs. Okay, so A won 2 pairs. And then we have some ties. B won only 1 pair. C won 2 pairings. And D won 3 pairings. So D is actually the winner. D is the winner of the Condorcet method. Now there's different methods that use this technique, and what's different about them is how they handle the ties. So we could award points based on how many, like A has 2, B has 1, C has 2, and D has 3, but also for the pairs we could go ahead and give them a half a point. Some methods do that. So in this case the ties didn't influence our winner, but sometimes they might. So A and D would each get half a point. So let's make that 2.5 and 3.5. And then our other tie was B and C. Oh, everyone got a 0.5. So like I said, the ties didn't influence the winner in this case, but imagine if you had someone just below, like maybe C, and they had a bunch of ties. They could maybe push ahead of D. Okay, so that is 4 different methods that we've looked at. And isn't it interesting that, well, D did win twice, but you can get really different winners in each method. So in the plurality, just the straight up first choice of everyone, that's the only thing that counts, and you need to get the most. That was B. But then more people who preferred, A, C, and E, they actually gave their votes to D higher than B, which is why, you know, this D1 over B, which is why I think D is the winner of the instant runoff method. This one takes into account not just your first choice, but all of your rankings. So if your candidate gets taken out, then your votes will still count, and they go to your next highest choice. Then the point system is a really different philosophy, where you give points based on where the candidate is in the rankings. And people who tend to be in the middle, you know, top to middle, do well with that one. And then Condorcet is looking at, you have to win in the pairwise comparisons. So what if only A and B were running? So it looks at A compared to B, A compared to C, A compared to D, and A compared to E, and all of those combinations. Okay, so we will practice some of these, and thanks for watching this video.